Hello everyone, and welcome to another video about the Godot game engine. I thought it would be an interesting idea to take one of the existing demos that comes with Godot and turn it into a little VR example application and just walk through all the steps that are needed to turn this into a mobile VR experience. So I'm using a custom build of Godot 2.13 here. The only thing that's really added to this is the camera enhancements that I did a little while ago. In our previous video, I kind of explained why that is needed to do a VR implementation. Although I'll try and get to a point where you can still use the normal cameras in Godot and explain how far you can get with those before you need the new camera implementation. Now, just to have a quick look at this Navmesh demo, this is just a small little application that comes with the Godot demo applications, and it's a really simple concept. So I'll just start the game as it is by default. You have got this little platform, I guess that's what you can call it. There's little robots, and all that you basically do is you click somewhere on the platform, and the little guy just goes to wherever you clicked. It just tries to figure out the easiest path to get there, and it just moves down there. And it's a neat little thing. So basically, there's two things that they have implemented here. One is the clicking to make the guy go somewhere, and the other one is to be able to rotate the camera and say, well, I want to be able to look from somewhere else where we are and see what this little guy is doing. Now, when we're looking at changing this to a VR game, obviously the most striking difference is we don't have a mouse pointer in VR. With some of the newer headsets, obviously, you've got little Bluetooth controller thingies, and that is definitely something that I want to look at in the future. But for this implementation, I'm going to have a look at just the basics that you get with like an original Gear VR or an original cardboard or one of the many simple HMDs that are out there that you can get for, I don't know, 20, 30 bucks at online or something like that. Those sort of environments or those sort of headsets, they allow you to look around, and you're basically selecting everything with gaze, and you've basically got one button that you can press on the headset. The original cardboard did that with a magnet. I'm not going to be looking at that for this series. But all of the newer headsets, and I think including the Gear VR, allows a tap on the display to be equivalent to a click, and there's usually a little a little button with a little lever or something like that enables that click. And that is the basis of what we'll be doing here for this little series. Obviously, we can't cover everything in one video. We'll be doing a couple of videos for this. This one, I purely want to have a look at setting up the stereo camera and how do you render that to the output or to the screen. The next one is probably going to be about making sure that you have lens distortion. So we're going to have a look at the lens distortion implementation and talk a little bit about alternatives that you can do there. The third one I'm planning to do about orientation, so when you move your head. After that, probably one that allows you to move around the world in some way, shape, or form, and then probably a last video to actually make the little guy move around by looking at a part of the little platform and clicking the screen. That's what I'm planning. We'll see if it actually goes in there. I might break it up slightly differently. We'll see how timing-wise that goes. So the first thing that we need to do is replace the camera implementation in this little game. And if we look at the original implementation, we see that we have a camera base, which is the point around which our camera moves, and then the camera itself, which we're using to look at the platform. We're not going to use that at all. We actually want a completely different implementation. But instead of removing that, I'm just going to disable it for now, just because I want to be able to keep the code running and have a look at that code and what we need to transplant into our new implementation. Now, instead of adding our camera directly into our main scene, we're actually going to create a subscene in which we put our whole camera configuration, together with its own GG script that contains all the camera logic that we need to render out the stereo camera properly. First of all, this gives us a camera that we can reuse for other projects. But also it would allow us in, maybe if you have a game that you want to deploy on a normal desktop and on VR, it allows you a method where you can exchange the subscenes for, a mono camera, or, a mobile VR stereo camera, or, maybe some other camera implementation, depending on the platform on which you deploy it. It's a good way to do it more modular. For now, I'm going to place all these files just in the root. Keeps it nice and easy for our little example here. But the final implementation will probably be something that that we store in a more structured place. So let's begin by creating our new scene. The first thing that we need in our new scene is a root node. And I'm going to just place a spatial there, and we're just simply going to call that stereo camera. Nice and easy to see what that is. And we're going to basically leave all that default. That's just going to be the origin of our camera. We need two cameras. Now I'm going to on purpose start off on the wrong foot, and I just want to show why we're building things the way that that we're building them. So we're going to add our two cameras in. Obviously, we need a camera for our left eye. So there's our left eye camera. And I need a camera for my, oops, I always do that wrong. I need a camera for my right eye. Why is that not showing nicely centered? Let's move that in. There we go. Now, our two little cameras, they are now at the still at the same position, which it doesn't really work for us. Obviously, we're going to be setting the positions in code, but I kind of like the scene to actually reflect what we're doing. So just to make our lives easy, I am going to position these cameras, and I'm just going to be basing that on our standard. 65 or 6.5 centimeter IPV that is a pretty good average for most people. Now, notice that I'm actually putting that at 0.035, and the other one is minus 0. Oops, I almost did it wrong. 0.035, and that is because I am setting this all up as if a unit equals 1 meter. We might need to fine-tune that depending on how this is set up, but that scale is important. Your units in stereo rendering are important because that is going to define the impression of scale, and especially with a head-mounted device. Setting that up wrong in the way that your scene is put together could either mean that that you're going to feel that you're a little tiny insect in your world, or otherwise, you're going to look at a little toy-sized world that's somewhere in front of you. So yeah, I know that, for instance, when you look at the Vive, where you of course have room scale tracking, everything is done by 1 unit equaling 1 meter. Which is why I generally start there. What I do very often in setting up is to choose a unit that is more commutative. Like, for instance, we'll see in a minute that we're actually setting the IPD and the screen size in centimeters, and then calculating it back to meters if required. Okay, let's save the scene and actually put it into our main scene and start building from there. So I'm just going to give it the default name stereo camera, which it takes from our root node. Nice and easy. And I'm basically just going to use a little link button to bring in the stereo camera, and there we go. Our little stereo camera is in our world. Now, right now it is, I think, probably somewhere down there. So I'm actually going to move it out a bit, and move it up here a little bit, and rotate a little bit, and we'll see in a minute whether, oops, wrong way, whether that is correctly oriented, but we just need a starting point for our orientation. Okay, that didn't work the first time. I had to make a quick change. First of all, turning the original camera off properly. It turned out not to be enough to turn off the cam base, and I actually hadn't got the orientation of my stereo camera correct. So I quickly adjusted that, and now when we run our project, we actually see our little Navmesh. Now, this is only one camera being rendered, and that is because by default Godot doesn't have support to render in stereo. We actually have to build that ourselves. Godot standard has got just one camera rendering rendering to our 3D, and that is or our default output, and that is the camera that is set as the current camera. And I believe that if none of them is set as current, it'll pick the very first camera that it finds. However, we need to render this in stereo, and the way that we're going to do that is by using viewports. Viewport is a construct in Godot that allows us to render out a copy of our scene either to a window like we have over here. So this is basically a viewport. For those who know Godot, the editor is actually written in Godot. So everything you see in the editor is what you could build yourself in a Godot application. So that's our first option, to use a viewport. The other option with the viewport is to use the viewport as a render target, in which case our scene is rendered to a texture, and then you can use that texture as input in the final result. And that is what we are going to do, and we're going to do that for each of our eyes. So let's start by creating our first viewport. And that viewport we will call, good question. What should we call that? Well, viewport left, why not? There we go. And we want to have another viewport, which is going to become our viewport. Come on. Right. Okay, so we have our two viewports, but now we have to start setting them up. The first thing that we need to do is give them a size, and again, just like with our spacing of our cameras, we'll be setting that in code. But again, I do like to set something up by default here, just that we have some things to look at in our editor. Oops, there we go, 400, 600. So that's going to be a total of 800 by 600 as a default resolution. We have to turn this render target enabled on both of our render targets. And the other settings we can pretty much keep the way that they are. Update mode, we could actually do that always, but I think when visible is enough for our goals today. The other thing that we need to do is actually move our cameras into the viewports themselves. So our left camera is going to render to our left viewport, and our right camera is going to render to our right viewport. Now, as I mentioned, the camera is actually rendered to, or the viewport's rendered to a texture. We now need to make sure that that texture is output to our screen, and for that we need two viewport sprites. So we're going to add a viewport sprite for our left eye, and we are going to add a viewport sprite for our right eye. Now these are both created in the root of the stereo camera, but we need to further configure them. First thing that we do is we assign our viewports sprites to the viewport that we want to render. Now notice that the moment that I do that, it sizes our viewport. And that is because our viewport sprite automatically gets the size of our left and or our viewport that it's rendering. Now I want to turn it centered off so that it's nicely at the left top of my my screen, and we're going to do the same to our right sprite, which we are going to assign to our right viewport. Again, turn the centering off, and now we're going to position that simply by putting the X to 400. So we've got our left sprite on the left side and our right sprite on the right side. And when we run that, we should now have two cameras. Now, that doesn't look right. All of a sudden, our cameras look really weirdly positioned. And this is because we have moved our cameras into our viewports. And our viewports they're not actually based on the spatial node. So they don't actually have any position information, and as a result, our positioning gets lost. It's a bit of a pain. So even though we've nicely positioned our left eye and our right eye cameras where they should be, that is not retained. So it's time for our very first little bit of coding. To make life easy, I tend to add just two placeholder spatials into my scene. I'm just going to put them at the top, and I'm going to call that left position, and maybe eye position, and create add another one. And call that right eye position. So these are just going to be little placeholders. Again, I'm going to move them where the camera origins should be in relation to our root node. There we go. So these two should be now exactly where our camera should be. And now it's time to write a first bit of script. So let's add a script there. Now I'm just going to need to use the default name, stereocamera.gd. There's a little start, and we're going to do a little bit of setup here. So the first thing that I like to do is to create some variables that give me some easy access to a number of the things in my node structure. So I'm going to create a left eye pulse variable and a left viewport variable, a left eye. Well, you get the idea. Left sprite. Okay. Can't get used to not doing semicolons at the end. Let's copy these and create the right eye versions of these. Obviously, we need to make sure we've got some values in there. So that is going to be left eye pos. And that's going to be viewport lefts. And our camera. And finally, our left sprite. Could have probably named those a little bit more consistently, but in the end, a rose by any other name, I believe the saying goes. So let's duplicate that for our right eyes. That becomes right. 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 Oops. don't know if it is case sensitive, but just in case. There we go. Got a tab there. All right, and then we need to make sure that we have our process turned on. Process set to true means that this function process gets called every frame, and all that we're going to do here is copy our position of our left eye pause into our left eye camera. All right, so that is very simple. Left eye dot set global transform to left eye pause dot set global transform for one eye, and I will do that for a right eye. There we go. And that means that as our camera moves through the world, and linked to that our left eye pause and right eye pause move through the world, those absolute positions in the world and absolute rotations in the world get copied into our cameras, so they actually get positioned correctly. Let's see if that works. Oh, I forgot something. Oh, I might want to call that get global transform. Let's try it again. There we go. Now we see that we have two viewports, a left eye and a right eye viewport. I'm not quite sure what happened to the lights. We'll figure that out in a little bit. But this is our first step to stereo rendering. All right. Now the other problem that we have with this is demonstrated when I resize this. As you can see, we still have our original scene rendering in the background. And I was a little surprised by that, but it actually turns out that because we have our camera still up and running here, even though we've turned it off, it still acts as a default. I still don't really want to delete it, so let's just, for fun, change the type and just change it to a spatial, just so that it no longer plays a role in what we're doing. Let's see if that works. Because obviously there's no point in rendering the scene in the background because that's just spatial. Perfect. That is exactly what we want. The other thing that's kind of important is right now our two little viewports are sized equal to each other, and it nicely fit up my screen because I set my default resolution to 800 by 600. But obviously we want the viewports to be sized according to our actual output, the resolution of the your mobile phone, if you're using a mobile phone for this, or as we're testing here, we want it to be the resolution of our window. So let's do that as the next step. Okay, so we're back in code where we are going to write that bit of logic, and it's quite simple. We're going to make a little helper function for this, which we're going to call resize, and obviously we need to make sure that we call that on our setup. And all that we're going to do here is start sizing everything. We're going to start by getting our screen size, which is our final output. And you can simply get that from get OS window size. There we go. And I like to copy that into a variable called target size, in which we are actually going to define what our individual window size, viewport sizes are. So we're going to take the half of our width, and we're going to take our full height. So for our 800 by 600 window, we'll end up again with our 400 by 600 window over here. Now we need to first of all assign that to our two viewports. So we're going to start with assigning that to our left viewport first, which we do with setRect, which takes a rect, which is 0.0 on the left, and that variable actually doesn't matter much in this case. And our target size. There we go. And now we do the same for our right viewport. To size. Close that one, close that one. All right, that just took a minute. So that resizes our viewports correctly. And now we simply need to move our right viewport sprite to the correct position. So let's do that one. And say, right, because our left sprite is always at 0.0, so we don't have to change that. But our right sprite, we simply move. Let's set pause. 2. So we want to have our target size x, to keep our y as 0. So at this point, we shouldn't see much difference. Because, right, there needs to be an R in there. Sorry about that. There we go. So we shouldn't see much difference because we were already sizing them to that size. But it should be correct for our normal output. But just as an extra, what I want to change is that when you resize a window, is that we actually size our or resize our viewports and our sprites to match our new window size. First of all, because we don't get this ugly, empty space, but also just to test if our logic is working at this point in time. So what we want to make sure is that that resize function gets called whenever the user sizes the window. Now again, this is only for testing purposes. You don't really need this on a mobile phone for the HMD because obviously you can't resize the screen on a mobile phone. But I do like to have this as some support that we need. Now, it does make it handy to test. So all that we're doing is we're connecting ourselves to the size changed signal that is on our root node. So that's our absolute root node in Godot, and we are simply going to call our resize function. So the signal is size changed. That's what we're reacting on. We're going to call a method on ourselves, and we're going to call the method called resized. So when we run it now, we should see that this beautifully resizes both of the viewports. Okay, so far so good. At this point in time, we actually have a serviceable solution. And let me actually quickly start this up again. I shouldn't have closed this. Provided the fact that our cameras are now correctly positioned for our eye spacing for a an average human being, an average adult. But the thing that is a problem for our solution at this point in time is that the center of our screen, with a normal camera, is actually the center of the screen. Sounds a little bit ridiculous, but that is really important because you have to realize that this is actually going to be rendered on the LCD screen of your mobile phone, or on the screen of the head-mounted device. And it's very important that the center of the scene, the center of what we're seeing, is actually right in front of the center of your eyes. Now, with the eye distance being at 6.5 centimeters for the average human, that means that if the width of your mobile phone is twice that, so roughly 13 centimeters wide, you're pretty much in the center. Take a Samsung Galaxy S7 or an iPhone 7 Plus. They are around that mark. The Samsung slightly bigger, the 7 Plus is I think slightly smaller, but it's close enough that your eyes are going to be happy with this setup. and the only thing you really need to do is start playing around with the field of view on the two cameras to make sure that that lines up with what your HMD is actually doing. But for any other sized phone, either a bigger or smaller phone that you're using, hopefully bigger. I'm using an iPhone 7, which is unfortunately smaller and therefore has a pretty much limited field of view on my head-mounted device. But of course, the more bigger you go, the more smaller you go, that center point is going to shift. So for my iPhone, it's actually about here, so on this ring. And that's really going to be noticeable when you look around, and the objects aren't moving around the way that your eyes expect them to, and yeah, you get very painful eyes pretty quickly at that point in time. So while this is serviceable for those couple of phones that are the right size, we actually need to start using our frustum cameras to adjust the screen to match other size displays. Okay, now in this case, or for this, we're really going to start looking at some code that I've already explained in my previous video. So we're just going to start typing it in, and we'll go from there. First of all, all the settings that we need, I'm going to record here as export variables, so we can actually start setting them up in the scene, and make them accessible eventually from the outside, so that we can add some setting screens at some point in time. Which I'm not quite sure if I'm going to make that part of this video series or not. We'll see how far we get. Anyway, the first one we need is the, actually I'm going to rename this slightly differently, and I'm just going to go with that IOD. So that's our interocular distance, so the distance between our two eyes, and I'm going to record that in centimeters. It's just easier. Actually, if you get that in meters, there's a problem with resolution because of the way that the variables are stored. We need to know what the width of our LCD screen is, which for me I'm going to default to 10.5 because, like I said, I was using an iPhone 7 for this. And I'm going to do one thing slightly different than what I did in my previous video. And instead of recording the distance between the LCD screen and our eyes, I'm actually going to record the distance between our LCD screen and our lens. And that'll be more explained further once we start looking at our lens distortion in the next video. But I'm copying this actually from the way that Google Cardboard provides the information that it needs to do the proper lens distortion. And basically, from what I gathered so far, that distance is assumed to be halfway between the eye and the screen if you didn't have any magnification in the lens. And on that basis, we're going to start setting up our view frustums. Anyway, that's as far as I really want to go with that in this video. Hopefully, we'll get some more explanation of that once we start looking at that lens distortion. The other two variables that I want to export is our near and our far variables, because we will be setting those in our logic, and we just want to have a way to make that settable from our main application. All right, just like with our resize. Oh, sorry for scrolling around a bit. That's my trackpad misbehaving a little bit. We're going to add a little function that actually does our updates for us, which we're just going to be calling from our ready for now. Well, we always need to do that, of course, from the start. But again, later on, we'll be able to call that whenever we make changes to our settings, so that we can update everything. And let's start implementing that. And this code should be pretty familiar from Nope, I renamed it to IOD from my previous video. So in this case, I'm going to take twice the ends. I'm pretty sure that I can actually remove those two Godots and two Godots from there. I might optimize that in a minute. Again, I'm just actually doing this slightly different for the first time, so let's see how we get there. IOD, again, we divide that by half, and again we divide that by. I'm probably going to change that in a minute. But I know that it's going to be working in if I set it up like this. So let's not break it just yet. There we go. So those are our three factors that we needed to calculate. And now it's a simple matter of setting up our cameras. So that's our left eye for our left camera. Oops, that's frustrum. There we go. So that's our new function. Okay, now here is another thing that I'm doing differently from my previous video, and I suddenly realized there is another thing that I need to change for that first, which is that we need to put this to keep width, and this one as well. Again, like I explained in my previous video, the keep width and keep height aspect ratio functions define whether the height of what I'm rendering or whether the width of what I'm rendering is locked by the field of view as you resize windows or resize your viewport and your aspect ratio changes. Now we want to lock in the width because everything that we're doing to calculate our frustum definition is based on that width. So if we would suddenly start changing the field of view in the horizontal plane, our calculations start screwing up, and this just makes our life a lot easier. And if you look at the previous video where I explained all this, you would have seen that I was dividing by the aspect ratio in quite a few places, and well, this cleans up our calculations quite a bit. So let's do the same for our right eye, but in this case, flip these two around far, and that should set our two cameras up. Oh, the other thing that I do like to do is actually change this to frustum. It would do that automatically. At least we can see what we're doing, and we'll tweak those figures a little bit later to actually see what that frustum would normally look like. So we've got a good example going in our scene. And again, we're overwriting everything in code anyway, so it's more for prettiness other than functional. The last thing that we want to do is position our eyes in the right place, and I'm actually going to add one more variable to my exports, which is going to be our world scale, and I'm going to set that to 100. So basically, what I'm saying here, because everything here is set in centimeters, is we're saying, you know, there is 100 centimeters to our scale. So we're basically going to divide everything by that to get everything in the scale of meters. Now we don't have to do that for the code that we've done right now, because, you know, dividing all sides by the same amount will still give you the same factors, but we do need that for positioning our eye positions to our IOD. So let's do that. Left eye pos set translation. Yep, to 3. This one goes minus IOD times 0.5 divided by world scale. There we go. And oops, we do the same for our right eye, but then that goes in the positive. All right, I think that's it. Let's give it a try. All right, now I should have taken a screenshot of the before and after, so we could actually have seen what was going on. But you can see if you compare the two images, this big circle, you can see how much that's shifted to the left on our left eye, while that same circle is moved to the right on our right eye. Well, unless you actually put a headset on to try this with, we won't know absolutely for certain whether this is correct or not. But I think that is enough for this very first video. I think this has gone on much longer than I actually expected it to take. So yeah, I'm leaving it at this. I'll spend some time before I do the next video to find out why my lighting has screwed up, and make sure that that this is indeed rendering correctly. Well, whatever I need to change, I'll explain in the next video. And like I said in my introduction, the next video will start looking at the lens distortions, because if you remember from my previous video, the field of view right now is very limited. And again, you know, if you are using a cardboard device with a small phone like an iPhone 7, that is how limited your field of view really is. The moment you start using a proper head-mounted device with some good magnification lenses, we start increasing that field of view. But obviously we need to adjust our view thrusting for that, and we need to apply our lens distortion for that. But that's the topic for our next video. So next time.